Good morning friends, welcome back to Parnika tutorials. In this video, I want to discuss one of the gate question which came in the year 2004 related to paging. So I request everyone to watch the complete video for better understanding. First let me read out the question, then I will discuss the solution with you. Look at the question. In a virtual memory system, size of virtual address is 32 bits. Size of physical address is 30 bits. The size of a page is 4 KB and size of each page table entry is 32 bits. The main memory is byte addressable. Which of the following is maximum number of bits that can be used for storing protection and other information in each page table entry is? They have given 4 options. Option A as 2, option B as 10, option C is 12, option D is 14. We need to solve the question and find out what is the right answer. If you look at each statement in the given question, size of virtual address is 32 bits. So they have given the logical address as 32 bits because logical address and virtual address is same. If they have given the logical address as 32 bits, we can find the logical address space or size of a process is 2 power 32 bytes because they have given that memory is byte addressable. And if you look at, they have given the size of physical address. Physical address they have given as 30 bits. If they have given the physical address as 30 bits, we can find the physical address space or size of main memory as 2 power 30 bytes. And they have given the page size is equal to 4 KB. Okay, and size of page table entry size they have given 32 bits. Okay, are you able to understand? I hope it is clear for you. 32 bits are there in the page table entry. Okay, and the main memory is byte addressable. Now what they are asking, maximum number of bits that can be used for storing protection and other information in each page table entry. If you look at the page table of any particular process, because each process will have its own page table, okay, the number of entries will depend on number of pages. Okay, suppose let's take that for a particular process you have 16 pages, then you will have 0 to 15 pages. Is it clear? Now if you look at what they are asking, they have given that size of each page table entry. They have given that size of each page table entry is 32 bits. Okay, now what they are asking, number of bits required for storing the protection and other information in page table entry. If you look at one page table entry, it will have the frame number, it will have the cache enabled or disabled, dirty bit, validity bit and protection bit. So they have given the page table entry size is 32 bit. Now they are asking how many bits are required for storing protection and other information. So storing protection and other information, and they have given the frame numbers as totally as 32 bits. So now we need to find the number of bits required for the frame number and subtract from 32, we will get the storing protection and other information bits. This is what the given question. Now to find the number of bits required in a frame, we need to find the number of frames. Okay, so first let me find out the number of frames in a main memory, which is equal to main memory size by frame size. Now main memory size is nothing but the physical address space, which is nothing but 2 power 30 bytes, and frame size will be equal to page size, which is 4 KB. 4 KB is nothing but 2 power 2 into 2 power 10, which is equal to 2 power 30 minus 2 power 12, which is equal to 2 power 18. So you have 2 power 18 frames are there. Okay, let me write here. Number of frames is 2 power 18. If you have 2 power 18 frames are there, number of bits required to represent a frame is how many bits? Is 18 bits. Am I right or wrong? Suppose let's take that you have 4 combinations. Then how many bits are required? 2 bits, because each bit can store either 0 or 1. So it will be 0 0 is one combination, 0 1 is another combination, 1 0 is another combination, 1 1 is another combination. Similarly, if you have 2 power 18 frames, then you need 18 bits to represent one frame. So we got the number of bits for a frame in a page table entry is 18. Okay, and storing special information, everything, let's consider that is x bits, and total bits in a page table entry is 32 bits. So if you want to find the x, 32 minus 18, which is equal to 14. So you need maximum 14 bits to store the protection bits, cache enabled disabled bits, validity bits, dirty bits, others is 14 bits. So the right answer for this question is option D, which is 14. I hope you have understood how I solved this question. If you still have any doubts related to this question, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.